So, good evening, students, and welcome to the first session in ours on database management system purely for the purpose of TCS Digital Round 2. So, in this session, we will look at the common questions that you can possibly expect when it comes down to DBMS in your TCS Digital Round 2 interview, which will be, as we know, a verbal interview as well. So, let us begin with this without any delay and look at all the sorts of questions that we can possibly expect when it comes down to this domain. So here's the first basic things we just need to know to begin with. So the first thing you can expect is when we talk about DBMS, we need to know that DBMS stands for Database Management System, in which we will look at all the kinds of questions based on normalization, normalized forms, joins, and hacking SQL kind of questions that you can expect when it comes down to DBMS. So throughout the session, as always, if you guys have any questions, any thing that you would like to ask, you can feel free to do that, and I will make sure to answer the same as well. But let us go on and begin with the very basics of this. Now, the first thing that you're going to be expected to know is that when you talk about DBMS, there are two basic categories of database management systems or database management softwares. They are SQL and no SQL, or we also call them as relational databases and non-relational databases. So for the first few minutes, I'll be going through a few basic things so that all the students from different branches like EC, EEE, mechanical, and everyone who may not have had the exposure to DBMS will get to know a little bit about it so that we can begin with the interview questions. So let us begin this without any delay here. So when we talk about relational databases, what we mean by this is the kind of books that we see, that is ledgers that we see. So the basic idea for this is, think about this. You may have seen some library registration book or library book where you have columns of data, or column, in each column you have certain things like serial number, book name, and so on. And in each row you have data such as let's say first book to be given out by the library, second book to be given out by the library, and so on. So basically, yes, as one of you stated, it just means you have rows and columns of data. So this is just like any book that you maintain, which is row and column wise data, which I will show practically using MySQL Workbench. And all the things that we will be learning, we will be doing here in this session, we will be going through this practically so that you guys can go through the same thing and try to learn the same as well. So let's begin this without any delay. All right, perfect. So now that I have made sure that the password is also available within this, let's go ahead with this. So the basic idea is, let's look at this for instance. Now, take this for example. Let's say I just do something like just select a database. Now this in detail I'll be showing it to you guys further on, but for now all I want to show is what exactly does a relational database look like. So I have a question before that. That is it compulsory to learn DBMS for EEE students? Most probably yes, because most companies including TCS hire full stack developers who need to know object oriented programming as well as, I'll repeat, object oriented programming as well as database connectivity and a little bit of web as well. But they will be training you guys further on. But these are some basic things you need to know. So let's just take some table over here in this schema just to show you. For instance, I'll just take something like select star from customers. Let's just run this. Now the moment I run this, you guys will be able to see a table of data like this, and the table of data here looks something like this. So the idea here is you get your customer numbers in order. That is, in each row you have a data. Each row there will be data. There is customer numbers, you have a column for it. Customer name, you have a column for it. Contact last name, contact first name, phone number, address, whatever it is, you have columns for them. And each row will consist of one person's detail or one entity of data, basically, is what we state. Now, going ahead with this, I have one more question. Many students faced issues with editor during digital exams. I don't think they will be conducting again, just to clear out one of the questions that I've just received. So, going ahead from this is basically how it looks like. Just like you can think of a book where people enter their data in each row with column names as headers of the data, it's similar to that. There's nothing else that is way too different about it. Non-relational databases are where data is not stored in a tabular form. Here it's stored in a tabular form. Non-relational database is where it's not stored in a tabular form. It could be stored in anything else. For example, it could be stored in JSON form. JSON stands for JavaScript Object Notation. This is a common form that is used for databases to store data, especially with the usage of mobile devices right now. Google has something called Firebase, which is an online non-relational database which stores using JSON notation itself. This is one of the examples that you can take. Similarly, when you talk about tabular form, one of the examples that you can take is structured query language, where we use our particular SQL, that is structured query language, to access tabular data. So there are a lot of softwares that generally use this. That is, a lot of softwares which do let you store and access data like this using certain languages. Those softwares include Oracle SQL and MySQL as well. Whereas when you come to non-relational databases, softwares you can possibly use is a cloud-based software, that is Google Firebase. You have something called MongoDB, which is hugely famous as well, and HBase for big data analytics, and you have CouchDB and so on. There are so many of these where things can be stored in JSON format, things can be stored in document format, anything except tabular form. That's the basic idea. So when we start with this, the first thing that we basically need to know, before going on, I do have a couple of questions here. There is difference between SQL and MySQL. Guys, please observe and note this very clearly. SQL is a language. I'll repeat, SQL stands for Structured Query Language. It's a language just like C or C++, with which you can access something, or which you can access, let's say, a tabular data. You can delete some or edit some, do whatever you guys want. And the software through which you use these languages are these software. For instance, the software that we are using here is called MySQL. And in MySQL, the code that I'm writing here, that code is basically in your structured query language. So that's the basic idea. So I have one more question regarding this. Will panel ask us coding questions during interview, or will it be focused on core concepts and subjective questions? It's going to be a combination of both, most probably. So make sure you are good at as much as possible when it comes down to this. So going ahead with this, one of the first questions that you can expect when it comes down to this, whether it's relational database or non-relational database, is that if you're from EEE, EC or any other branch, you don't have to particularly know everything about everything. Since it's something new to you, learn relational databases really well, because that is what they would expect you to know better. If you know this really well, then you can possibly focus on non-relational database a little as well. But first, let us focus on relational database in our case and start learning a few very basic things that we need to know. Say, the first thing that we need to know is, or the first question that is commonly asked is, Okay, you know about databases, you know the basic concept of DBMS. So tell me, if you're building your own database, what are the four properties that you need to follow to build a good relational model or database? So these four properties are generally specified in one word as ACID properties, and they stand for atomicity, consistency, isolation, and durability. Now, I'm not going to go in depth within this, but I am just going to focus on this so that we know the very basic concepts of these so that you guys can easily answer them. And again, I'll repeat this. The initial few minutes of the session will be focused in such a way that all branch students can easily get through and understand this. So EC, triple E, mechanical students, this is mainly so that you guys can get to know the very basics, so that once we start with some more advanced questions, you guys are at the same level as CS students when it comes down to basics at least. For CS students, this can be more of a revision at this point of time. So let us begin with this. So think about this, guys. When you talk about atomicity, the idea of this is when you have an atom cannot be divided further, or an atom cannot be broken down further on. So the basic idea here is that any transaction, when I say transaction, any query that you put up in database, if you're updating a database, if you're deleting something from a database, whatever it is that you're doing, anything, any transaction that is happening with the database must either happen fully or must not happen at all. It should never be half done. That is, let's say if you're putting up some money in ATM as a transaction, it must either submit it like in a cash deposit machine. It must either submit the money to the cash deposit machine and make sure that it is reflected in your account, or it should not do all of it. It shouldn't do half of it. That's the basic idea. Any transaction is either fully done or not done at all. This is basically called atomicity. So going ahead with this, the next thing that you guys basically need to know is consistency, isolation, and durability. So here's basically what consistency means. Consistency means that if you're performing a transaction, any transaction performed, if they ask about this, it's something that's basically need to know. Any transaction performed repeatedly, even when you perform a single transaction 5 times, 10 times, any number of times, should provide same result. It should not give you different results each time. That's the basic idea. And isolation makes sure that any transaction done by you as the user does not affect other transactions done by other users at same time. That is, each one is isolated. Then the last one is durability, which makes sure that any changes made should be saved. This is the basic idea. So these are the four properties that we state are parts of a good relational model to be built. So I have one question before I go ahead. That is, please conduct one more session based on latest trend technologies. We do have that planned in the coming days. That is data structures, algorithms, and recent trends as well, so that you guys can make sure that you guys will be able to attend that and learn as much as possible within that as well. So not to worry, we do have such sessions planned. So stick around for our sessions further in the coming days as well. So let's begin with this in short. So the first thing here is, when you talk about relational databases or databases in general, there are certain terms that you guys need to know. Certain terms like a field, a record, an attribute, These are a few terms that you need to know. So there are so many other terms, but since we will be using these terms throughout the session today more than any others, I will be focusing only on these for now. So please note this, students. When you talk about databases, the three terms you need to know and realize well are these: field, record, and attribute. So when you talk about a field, here's the basic idea. A field is just, I'll repeat, a field is just one row of data. If you get a question in your interview like how do you retrieve one field, or how do you retrieve something like this, one field, or any such question, know what a field means to begin with. So these are certain uh, terms that we need to know when it comes down to this. So followed by this, the next thing is when you talk about a record is also basically just a row. And then when you talk about attributes, it's just a column name. So one row of data can either be called as a field or a record, and attribute is just a column name. So these are just a few basic things that we just need to know. So now that we know these very basic things, let's go ahead and let's focus on the other questions that can possibly be expected. So that's one of the common questions is when you talk about DBMS architecture, they're gonna particularly ask what are the different kinds of architectures and where do we use different kinds of architectures. So guys, when you talk about this, there are three kinds of architectures that is called one tier, two tier, and three tier. And I will be connecting these architecture tiers with some other concept later on, which are again a few basic things that we must know irrespective. So one tier is basically where you, that is the user, can access database directly. Think about this, guys. I have my database stored here. I'm able to access it directly using my structured query language code. So this is a one tier database architecture. So just remember this, user can access database directly using SQL code. So I'm able to do this because I have the database in my own system and I know SQL. But in real programs anywhere, no user does this. That's because one tier architecture is used by developers and testers to make sure that the program works perfectly, and then they will convert it into the way where um, we provide it to users, where users can just click a button using a form of data or something like that and just submit the whole data which will be stored in database. So followed by this, the next thing that you have is something called two-tier architecture. Two-tier architecture is basically something like a client server system. This is something you guys need to know. A client server system where you have certain APIs to access database using code, again using code. So this is generally done while working through testing as well, and finally comes up with three tier, where when it comes down to three tier, this is where real life applications come up in. Think about this, you have a form of data online where you enter something like your name and something like that. Let's say you have a form of data. So I'll just make sure to open a new file and take a screenshot for you guys. All right, let's say you have a form of data, your name, address, and all these things for shipping of some products. All of these that you enter in a form is then sent as SQL code, for instance, into the database of a particular um, software that is into a database through SQL code which is stored in some server. So this basically is called three-tier architecture, where user interface is provided. User will just need to click one button like submit or something. Whatever user enters, that will be converted to your SQL code, which will be put into your database basically. So this is what is used in real life everywhere. So which architecture is used in real life for all web applications or mobile applications, wherever it is? There is three-tier architecture. So it has client, and then a middle layer, and server. So client basically has, here's the idea, the client basically has just a form which will be sent, and an application server communicates and converts into SQL code, and that is then stored in your database. So this three-tier architecture is what is used in real life applications. So let's go ahead with this. Followed by this, once we get to know about DBMS architecture, there is the three-tier architectures that we need to know. Once we get to know this, another question that commonly comes out, that is very common, is how do you differentiate, or what is logical data independence and what is physical data independence? So this is a very common question as well. So let us just try to understand what exactly is this particular thing called logical data independence and physical data independence. So to answer this question, we'll go a step back and we will see, based on a three-tier architecture, what will be the schema of it. So a three-tier schema looks like this. I'll tell you guys in short what exactly it is. So it's just that you have three things in a three-tiered schema. We already know that. So there are three schemas, or three different ways to visualize things. The first is called external schema, then something called conceptual schema, and finally internal schema. So when we talk about this three-tier schema, when we particularly go for external schema, it's just the same thing that we discussed earlier on in our three-tier architecture. This is the UI part that the customer sees, that basically the customer sees. Conceptual schema is the middle layer where you can understand. See, external schema is the UI part that the customer sees. So this is UI, you have name here and you have address here to be entered. Whatever is the UI, that is basically your external schema. From an external person's view, this is how it looks like. Now, conceptual schema is where you will show how the database looks like from the internal of the organization. So who requires external schema? Customers. Who requires conceptual schema? Programmers require it. So it basically shows the structure of database, that is, what is the table name? A table name can be customers. In customer table name, what are the data that are there? After customer table name, what other table name is there? It could be something called order details. So such details which are provided, what tables are there, how are they connected, all these basic things is called conceptual schema. Think of this is something very similar that you can state is a conceptual schema, where you're stating just what data is stored in what table. You can see that customer table stores these data, or order table stores these data. You're saying what is stored where and how are they connected, but you are not stating basically things like what is stored in each table. It's just a description. I will repeat again, guys. It's just a description of what are the tables, what is stored in each table. That's basically it. Now let's go on to internal schema. Okay, before we go on to internal schema, I have a question, that is, can you describe difference between two-tier and three-tier again? See, a two-tier schema is basically a client-server schema. In short, what happens is from the client side, you can either have UI or you can have code that you run directly. So you can either have UI as well if you like. So from the client side, whatever code or UI that you have directly goes to the server, which connects to its DBMS, and whatever you're entering will be stored over there. But nowadays, nothing gets connected directly from client to a server. So every time nowadays, what we have generally is a client, then another in your client UI. It goes to one server where all computations are done, where things like your connections to all the different pages are done, and from there it then goes to the database. So it doesn't go directly to database from client, that is, it doesn't go directly to the server database connected. From client it goes to an application server, from there it then separately connects to the database. So that's basically how it is done. So I hope that answers the question that is just obtained, that is just asked as of now. So going ahead from here, when you look at this, now that we are basically identifying what is external schema, that is from customer's perspective, what is conceptual schema, that is programmer's perspective, that is structure of database. I'll repeat, it's just what tables do we have, what column names or what attributes do we have, how are tables connected. These are the basic things that one just needs to know. Then comes internal schema. Internal schema is what is used by any person who wants to physically access the database. So internal schema is where it describes physical storage of the database. It basically describes the physical storage of database, that is where it is stored, in which hard drive is it stored, and how is the data backed up, and so on. A lot of things come up within this. So this is basically the physical description. So these are the three tiers. Now that we know the three tiers, we can now talk about the two important questions that are asked. That is, what is logical data independence and physical data independence? Think about this, guys. Let me ask you guys a simple question here. Can I change UI that the user sees without modifying the database structure? That's the simple question. That is, am I able to change the UI without modifying database structure? Or more specifically, can I modify or can I change database structure without modifying the UI? So logical data independence here states that your logical or conceptual schema, that is structure of database, whatever it could be, you should be able to change that without changing external schema. In short, I'll just repeat this: ability to change conceptual schema without changing external schema. This basically is logical data independence. Now that we know this, the next point is something called physical data independence, where basically all that we point out to here is you should be able to change internal schema without changing conceptual schema. That is, you don't have to change the structure of database, but you should be able to change, you don't have to change the structure of database, but you should be able to change where the database is stored. So the database can be stored in a certain hard drive, it can be backed up in a certain hard drive. You may want to store it in a different hard drive. So without changing anything else, can I change internal database? Yes. Or internal schema. That is basically called physical data independence. I hope that makes it simple and clear for us to understand these basic things on database. So these are the very basic questions that we can expect. Now, moving from these basic questions on DBMS, now let us go ahead and go for SQL directly. Now, I've stated before, SQL is structured query language, which some people also call as SQL. That is completely up to your pronunciation. Uh, but here, SQL is just a language, just like your C++, and all are programming languages. But this is a query language, in short, as what it states, where you just write simple queries to access data from the database. So, structured query language is divided first up into different parts, and here's how we divide it. We have divided into different parts as DDL, we call it something as DDL, and then DML, and then DCL, and finally TCL. So DDL stands for not movie names, it stands for data definition language. So these are all the commands which are used to create or modify the structure of a database. I'll repeat, all the commands used to create or modify the structure of a database, that is, add a table, remove a table, merge multiple tables, or add one more um, column within the table, altering a table. All of these things are things that change the entire structure of database. That is why they are called data definition language commands. So the commands are divided into these following parts. So when you talk about DDL commands, so there is something called create, which is used to create a database. There is something called alter, which is used to modify the structure of a table. So that is also data definition language technically, because you're creating a new definition for your table. Apart from this, you can drop something, you can rename something. Drop means to remove, you can rename. All of these are parts of data definition language. Then there's something called data manipulation language, where you modify things within the table or retrieve things within the table. Things like you want to select something, or you want to update something, you want to insert something, you want to delete something within a table, and so on. All of these come up under data manipulation languages. Then there's something called data control language, where you can either give or remove control from a particular person. To give control to a particular person, we use grant. To remove control from a particular person to access database and everything, we use revoke. These are the two commands. Then comes finally transaction control language, which basically is used to either store data or not store data. To store data and save the data within your database, we use commit. To cancel saving of data, we use rollback. So both of these features are there, which help make sure that atomicity exists. So now that we know this, now that we know the very basics of this, I have one question before I go ahead. The question is, explain DDL again. See, DDL is basically all the commands which are used to modify the structure of your database. When I say structure of your database, things like adding a new table, or removing a table, or renaming a table, or adding a new attribute in a table, whatever it could be, all of these come up in such a way that they modify your view, they modify the entire view of the table. So that's the basic idea, guys. So this is called data definition language. So let us move ahead from here and try to go through the next set of questions that you can possibly expect when it comes down to this. So the next question that I would most often state that you will expect when it comes down to this is the very basic and most commonly asked question. I'll repeat, this is one of the most commonly asked question, that is on keys. So keys are basically, you can say keys are attributes. What are attributes? Attributes are just your column names. So each column name, you can say, is basically a key. And there are different kinds of keys. All of them are divided into different kinds of keys. So let me just go ahead and explain what are the different kinds of keys you have so that you get a better idea. So this is often asked, and this is the most common question when it comes down to DBMS. So you have different types of keys, such as you guys probably, some of you already know, primary keys. Then you have something called candidate keys. Then you have super keys and foreign keys. So to understand this better, since some of you may be new to this, let me just try to point this out. I have one question, that is it same as physical conceptual view schema? Yes, at that question, basically yes. So I have one more question. What coding questions to be expected? See, if any, the basic coding questions you can expect is something that you can explain the logic to them then and there as quickly as possible. So something simple like, if there is a program to do palindrome, what logic will you use? If there's a program to do something else, what logic will you use? So these are some basic things that you can possibly expect. So from here, I have, okay, these are the major questions that I had. Okay, now that I've answered them, let's go on for this. So guys, think about it. I want to ask you guys a simple question. Let's take a student database in a college. So when you talk about student database in a college, you have a lot of things like serial number or registration number, and you have something called name, you have something called semester, you have something called which department they belong to, and stuff like what is their phone number, their address, and so on. So in this, what do what are how do I identify a particular student? Will I identify a student by their name, by their semester, department, phone number, address? No, we always identify a student by their registration number. Think about government corporations, or governments or corporations, or if you want to go create your bank account, you have something unique called account number. Every person has the account number by which they are identified, and you want to go and get something done through government, you have your own Aadhaar card by which everything is identified. It's not your name, it's not your phone number. In each place it's something different. Similarly, when you talk about something like let's say, for instance, when you talk about having your own mobile phone, and you want your mobile service provider to identify you, they will not identify you by your registration number or anything else. They will identify you by your phone number. So for each case, each table, or for each scenario, you basically have something like a unique column by which you're identifying the entire table. For a student, registration number identifies entire table, and so on. So that is exactly what is called a primary key. That is an attribute or a column, what you can say, that identifies entire row of data uniquely. So this is the basic idea, guys. So just know this: entire row of data will be identified uniquely by one thing. Take our current database, for instance. We have something called customer number, which is unique. No two customers can have same customer number. So there could be something like phone number which can be unique, or address which can be unique, or two people can share same, who knows, we have no idea. But even though they may be unique, even though phone number of every customer may be unique, we know that customer number is definitely unique, and that is what we are identifying everything within our company. So customer number will be the primary key for the customer table. That is exactly what primary key is. Candidate keys, on the other hand, are all the keys which are unique and can be a primary key. So is primary key also a candidate key? Yes. Candidate key are all the unique keys. So if you look at this, customer number is unique, customer name may not be unique. Two customers may have same company names, they may just, we never know. Their contact name could be same, contact first name could be same, phone number most definitely will be unique. So you can say customer number and phone number are both unique. So you can basically state that these two are candidate keys. Whereas address could also be unique, city, postal code, country, sales, country and everything, these are definitely not unique. So whichever are unique and are also not null, you have to note the condition. That is, primary keys and candidate keys should be unique and not null. Only in that case you can state that they are primary or candidate keys. So the basic idea here is, guys, just know and remember this: all the keys which are unique and can be primary key or candidate keys, one of the candidate key is primary key. Now comes something called a super key. So a super key is something slightly different, and here's basically what it is. Super key is just, I'll repeat, is just a superset of candidate keys. That's all. So registration number and phone number are unique. So take a set of registration number and phone number. This set is basically a super key because it's a superset of individual candidate keys. That's basically it, nothing else about it. Then comes foreign keys, which is something that is hugely important. And I'll state this: everything in DBMS revolves around the concept of these keys, and most of them revolve around this particular concept that is called foreign key. So to understand that, let me just take a very simple example. Take this for instance, guys. Let's say you have a table called customers, and let's say you have one more table called orders. So the table called customers here has something like customer number and let's say address and let's say phone number. I'm just gonna add customer name as well. So when you talk about orders, you have to identify that each order belongs to a certain customer. So you need customer number here also, because if you put up customer name, two customers may have same name. So how can we get to know whose address are we supposed to give it to? So having customer number here makes better sense. So when you have customer number here in orders, so you can identify, does customer one have any order? So you can check the customer number here also in order. So orders may have something like order number and ordered product and something like price and quantity. There can be so many things. So customer number here and in customers table are both same. So in this case, we know that for customers, primary key is customer number because that is what we identify customers with. In orders, order number is primary key. Primary key here is order number. So when you talk about primary key over in these both cases, for one it is customer number, for the other it is order number. But customer number, which is a primary key in one table, is also available in another table. So this is called foreign key. Basically, foreign key is when a primary key of one table, when a primary key of one table is also in another table to connect the two tables. That is basically called a foreign key. So think of this, guys. If I don't have customer number, I won't get to know which customer has ordered what. If I do have customer number, I'll get to know which customer number has ordered what, and I can get the customer detail by searching same customer number in my customers table. This is the basic idea. So I have one more question. There is one of you want me to give one more example for candidate key and primary key. See, I have given multiple examples. Take this for instance. When you talk about your mobile company database, your mobile company database identifies every customer using their mobile number. A company identifies every employee using their employee ID. All of these are basically primary keys, and other things like there could be their um, Aadhaar number or whatever else it could be there that is unique, which you can say is there, in other words, candidate key. So this is one way. You can just take one more example as well. So now that we are clear with that, and I hope everyone is also able to understand exactly what a foreign key is. Once this is clear, the next thing I will repeat again. When you talk about these certain things, what we are focusing on in our time of 2 hours is only the most important questions that you can expect. So the next thing that we're going to focus on is again a hugely important concept that is called normal forms. This is where a lot of students get confused in. I'll repeat, a lot of students get confused in. Even guys from CS, students from CS AC, or all of these get confused about. But let's just look at what exactly is normal forms, and how do we work through it. What are there, and so on. So if you want to make your database effective, if you want to organize data in your database in the right way to reduce redundancy, when I say redundancy, I just mean duplication. That's all. In DBMS, we use this term redundancy. So to reduce the redundancy, to make it more efficient and effective, and so on, we use normal forms. Now, these are the common normal forms we have. We have first normal form, second normal form, and third normal form, 3.5 normal form, fourth normal form, and fifth normal form. There's so many of them. Let us try to just understand them in short. And I'll repeat, these are the ones which are hugely important. I have one question by the time candidate key can be null. No, see, if a candidate key can be a primary key, can it be null? You can answer this. So because primary keys cannot be null, so we get a better idea here. So now that this is clear, let us look at what else we basically need to know when it comes down to this as of now. So here's the basic idea, guys. In here, when you talk about normal forms particularly, I'll repeat this, the first normal form just states that every attribute should be atomic. What do you mean by atomic? That means can't be divided. So in short, all that it states is, if you have a column called phone number, under that column you can't store the first phone number comma second phone number. You can't do this because these are multi-valued attributes. It can't be two different values. Atomic means it can't be divided further on. There should only be one. Now, why do we do this? Why do we need first normal form? When you get questions in interviews, you will not get questions like explain first normal form in its definition. You're going to get application oriented questions. You're going to get questions like, okay, why do I have to follow first normal form? You're talking about database, you're talking about normal forms. Why do I need to follow first normal form? Think about this. Let's say you have address as a column. In address, if you have something like house number, then street number, and after street number, let's say something like district and city, and then state, and then pin code, everything together. If I want to extract any single thing, if I only want to extract city to send to that city, if I only want to extract state to send to that state, or if I only want to extract pin code, can I easily do this? I can't. So that is where it becomes difficult. So if we divide this instead of address to different columns like house number, and then another column called street number, another column called district, another column called city, another column called state, another column called pin code, I can easily identify whichever part I want within it. This is the advantage of first normal form. So what it states is, in short, I'll just point it out and state to you guys, that is a single cell of data, a single cell of data, or in other words, an attribute. So yeah, an attribute cannot have multiple values. It can only have a single valued attribute. It can only have a single value. That's basically it. And the next point is, multi-valued attribute is also not possible. Multi-valued attribute should also not exist. That is, when you say multiple values, we separate it by a comma. When you talk about multi-valued attribute, you don't separate it by a comma. Think of it something like address. I may not even write a comma. I may just write state and then country directly as it is. So, or if I have multiple data, whatever it could be, so it should not be combined together. For example, dates. If I have birth date, so something like 30 11, let's say 2020 is the birth date. So if this is put up in one single cell, we can't get the date, the month, or the year separately easily. So if you store everything separately instead of a multi-valued attribute, it follows first normal form. So this is the basic idea of what a first normal form means. So I have one question, means first normal form cannot be foreign key or something like that? Nothing like that. See, first normal form just states that you can't have multiple values together in a single column. Think of this. Here, in address line 1, we have house number and street number and all of these together. Is this following first normal form? It's not following first normal form. Of course, city is in a separate place, postal code separate, country separate, and everything. But in address line 1, there are something separated by a comma. There are combinations of things. So it does not follow first normal form. That's the basic idea. That's it. So going ahead from this, let us now go on to the next point, that is, what is second normal form. Guys, the basic idea of something to be in second normal form is, first rule, it must follow first normal form. So if first normal form is not followed, it won't follow second normal form at all. So you can only check if a table follows second normal form if it follows first normal form. And here's the definition of second normal form. It states that all non-primary key attributes, every column which is not primary key should be fully functionally dependent on primary key. Let's see what exactly this means, because there are a lot of different dependencies we speak about, and instead of normal form, you can expect questions in interviews with just this term directly, that is fully functionally dependent. So what exactly does this mean and how does it work? So the idea here is, guys, think of this. Any key which is not a primary key should be completely dependent on primary key. Let's take one simple example, and this is a common example that we take, so I'm going to take the same example over here as well. So the example goes like this. Think of, let's say we have, let's say online sessions. So we have something like trainer ID, and then something like the subject that the trainer teaches, and then the trainer, let's say something like trainer age, for instance. So let's say trainer ID, we have 1, 2, 3, trainer ID 1 teachers, let's say C, trainer ID 2 teaches, let's say, Java, and trainer ID 3 teaches, let's say, for instance, DBMS. Now, in this case, let's say trainer age is 30, 50, let's take it as, for this 51, let's take it as, let's say, just 52. Now, don't ask why I selected these numbers particularly, no reason. So, in this case, the idea is, how will we get to know which is the primary key? Of course, trainer ID looks like the primary key here. What if one trainer can take multiple subjects? Can I write Java, something like C++ here? I cannot do multiple values here. That means it won't follow first normal form. So I have to create one more row here. That second row, next row will be something like, again, trainer 2 will also teach C++ and his age is 51 as well. Now you guys can see trainer ID is not unique, but combination of trainer ID and subject is unique. So you can say in this table, primary key will be combination of trainer ID and subject, because this combination is unique. This combination is unique. Trainer ID and subject ID together, subject together. Now, subject itself, what if multiple trainers take same subject, or age could be same for multiple trainers, or so on. So we will take combination of trainer ID and subject as a primary key. You can take combination of two columns as a primary key. There's no restriction about it. So when you take this combination as a primary key, here's the question that you will get. What is the second normal form stating? All non-primary key attributes. Both of these are primary key. Which is non-primary here? Only trainer age. So the idea is all non-primary key attributes should be fully functionally dependent. In other words, completely dependent on primary key. So let's see if it is completely dependent on primary key. We have two things in primary key, trainer ID and subject. Is trainer age completely dependent on trainer ID? Yes. Each trainer has a particular ID, and for that particular trainer we have age. Now, is subject dependent on the is trainer age also dependent on the subject? Is it fully dependent on the subject? Not at all. Because in our case, if I take, this is also, let's say, trainer 3 also teaches Java and his age is 25, for instance. And if I take this, let's say, trainer age is not completely dependent on subject whatsoever, because you have trainer age and you have subject here. So for a trainer age of 51 also there's Java, trainer age of 25 also is there in Java. So trainer age is nowhere fully dependent on one part of the primary key. So you can say that this non-primary key is not fully functionally dependent on the primary key. So whenever it is not fully functionally dependent on primary key, you need to perform something called, as one of you have stated already, decomposition. Decomposition means just splitting of tables. You need to split this table into two tables, so that in each table, whatever is non-primary key should be dependent on primary key. So how exactly would we divide it? Let's take, for instance, this certain table. We need to divide it in two tables. First table, I'm going to make it as, I'll call it as trainer and subject, which subject they take. So let us remove their age entirely. I don't need this. And the second case, I will take trainer data. So in this case, I'll remove subject entirely. I'll only keep trainer ID and age. So when I keep trainer ID and age, of course, there are 2 times 2 and 51 will occur, redundant data. Let us remove one of them. Now in this case, if you see, in my first table, trainer underscore subject, I can't have only trainer ID as the key. I can't have only subject also as the key, because both are repeating. So my primary key here will be a combination of it. That is again trainer ID and subject. So let's see if our second normal form follows here. Second normal form says that all non-primary key attributes should be fully functionally dependent on primary key. Is there any non-primary key attributes at all here? No. So we don't have to compare that. Here our primary key is unique, which is trainer ID. So we'll take primary key as trainer ID. So is the non-primary key, which is trainer age, fully dependent on trainer ID here? Yes, it is. So this is how we have basically decomposed or divided our table that we had before, so that every non-primary key is fully functionally dependent, or in other words, as I like to say, completely dependent on primary key. I hope this is clear to everyone. Let me know, guys, if there are any questions, any doubts within this. I hope it is simple and easy to understand with this one example for you all. So followed by this, let's now go on to the next keys, and I will not focus much on 3.5 normal form. I'll be focusing mainly on third normal form, fourth, and I will directly go on to fifth. If you guys are willing to learn more, you guys can go through and check through more about it further on. So let's go on and look at third normal form. So as you guys can guess, what could be the first requirement for a table to be in third normal form? It must be in second normal form. The idea is a table in second normal form must follow first normal form. A table in third normal form must follow second normal form. A table in 3.5 must follow 3. 4 must follow 3.5. 5 must follow 4. So in other words, if a table has to be in fifth normal form, it has to be in all the previous normal forms as well. That is the basic idea, guys. So with this, let's go on and check what exactly is third normal form over here. Here's basically what it means. So a table is in third normal form if, first condition, if table follows second normal form. Followed by this, the next point is why third normal form is required. It is used for reducing redundancy. It is used for reducing redundancy, not to eliminate redundancy. Remember, it is just used to reduce duplication, not to remove. There still could be duplication. You're not completely removing it, you're just trying to reduce it as much as possible. That's the idea. So earlier we saw what exactly fully functional dependency looks like. So now, all right, thanks for the comments that you guys have made, so that you guys have understood the second normal form completely. Perfect. Now, okay, I have one question that I have missed out. That is how to make it first normal form. See, any table that you have, just make sure that there are no mixed up data. Here you have in address, you have some house number and street number. Just give two separate columns instead, one called house number, one called street number. That would basically do it. That is basically all that we need to do. That's it. So I hope that is clear. So going ahead from this, in this case, when we talk about third normal form, now this is where you guys need to understand this clearly, because we talked about one thing before, that is fully functional dependency. That means non-primary key should be dependent on all primary keys together. Here it was not, so we removed this table and made it into two tables where non-primary key is now dependent on primary key. Now for third normal form, what you need to basically do here is you need to check for something called transitive partial dependency. Should not exist. That's the idea. Now we're getting confused, like, hey, we learned about fully functional dependency. Okay, that means non-primary key should not be dependent on, should be dependent completely on primary key. Now what is this transitive partial dependency? What changes now? Think of this. I'll take your simple customer data to understand this. Let's take a customer table. In a customer table, I can have customer number and customer name and customer, let's say, state, customer followed by, let's just do something like customer zip code, and finally customer city, and let's say basically these are what I need, and something like customer phone number. You guys can put up whatever you want. So when you look at all of these, you guys can have a lot of data within this. Like for example, there could be a customer name 1, 2 and 3. Customer name 1 maybe John, customer name 2 maybe Jane, customer name 3 maybe Jack. So phone, let's just give some values, and let's say state, John and Jane, let's say they say stay in the same, all stay in the same state. Let's assume that. So let's give the state as something like ABC. Let's say all of them stay in the same state, that is ABC. Now here's the thing. Let's assume two of them stay in same zip code. I'll give 112, 112, and only one person stays in a different zip code. But city again are also same. City could be like, let's say XYZ is the city for them. Here also XYZ is the city for them. Here also XYZ is the city for them. Now when you talk about this, there's a redundancy. Now what if you have 10,000 customers? When you have some data like 10,000 customers, there's a chance that out of 10,000 customers, if 5,000 are from same city, same state and same zip code, this data is repeated 5,000 times. Isn't that redundant? That is redundant. Now how do we get to know that this becomes redundant? Think about this, guys. Transitive partial dependency should not exist. What this basically means is, before going ahead, I have one question. Redundancy not means decrease number of tuple or attribute. See, redundancy means that you are decreasing duplication. Whether it is tuple, attribute, whatever it is, it's immaterial. You just have to reduce duplication. So here, if you guys observe, if we have 10,000 customers, and out of that, if 5,000 are from same zip code, same state, same city, this is repeated 5,000 times. That's one data, but it's occupying 5,000 times the size, because we are storing it in 5,000 different attribute, different rows. So this, to understand this, think about this, guys. Does this follow first normal form? Yes, it does, because all of them are unique. There's no multi-valued data whatsoever. Then followed by first normal form, does it follow second normal form? Is everything dependent fully on customer number? Is customer name dependent on customer number? Yes. Phone number? Yes. Their state? Yes. Their zip code? Yes. Their city? Yes. All of them are dependent on customer number particularly. Now the question comes up like, then what exactly is this transitive partial dependency? This means that there is something in this table which is dependent on one thing. Like, see, city is dependent on zip code, state is dependent on zip code. If I give a zip code, I should be able to get city and state. So state and city are dependent on zip code. That zip code is in turn dependent on customer number, because this customer lives in a particular area code or zip code, and in that area code or zip code you have certain state representing it and certain city representing it. So this is called transitive partial dependency. That is, state and city are transitively dependent on customer number. They are first directly dependent on zip code, and zip code is then dependent on customer number. So can I take this separately? That is the basic idea. So here, what we will do instead of this is, we'll take the same customer table. We'll take customer number as it is, customer name as it is, customer phone as it is, and customer state, not state. We'll just take zip code, because state and city are dependent on zip code. So I'll take customer zip code. Here we have 3 customers, and let's take the same thing, John and Jane and Jack. Followed by this, you have customer phone. Let's take the same thing. That is 1, 2, 2, 3, and 3, 4. Now you have finally zip code, that is 113. and 112 and 112. Now everything is directly dependent on customer number now, because state and city we have removed. Now since we have removed it, we have to put it in one more table, and in that table let's make zip code as our unique key or primary key. If I do that, I'll take one more thing called customer zip code, and then customer state, and then customer city. Now if you guys observe, there are only two zip codes that we have, 112 and 113, and both are in same state. So guys, both are in same states and same city. So in the previous case we had 112 repeated twice. In this case we have reduced the redundancy, reduced the duplication by 1. So all that we are basically doing here guys is observe, if there is any attribute which is dependent on another attribute, and that attribute in turn is dependent on primary key, you have to make whatever is dependent on the other attribute put in a different table. That will make sure whenever it is duplicated, it becomes one row only. Think about this. In this customer table, what if there are 10,000 customers who live in same zip code? In that case, I'll have 10,000 rows with this data itself repeated. Instead of that, let us remove city, let us remove state, let us only keep zip code. Zip code will be repeated many times, but that zip code is written with state and city only once in a separate table. This is the basic idea of a third normal form, where you are removing redundancy by removing any transitive partial dependency. Does this make sense guys? Is it clear? You guys can see this is already written thrice here, but we have only written it twice in this case. So I hope this makes sense. So if I want to get to know which state John stays in, all I need to know is get his zip code, go to this table and get his state. That's the basic idea. Does this sound simple and make sense? You guys let me know. So here primary key is again customer number, and here your primary key is customer zip code. So this is the basic idea. Now within this, there's one more point you can state. Remember guys, when I told you guys a primary key in one table, if the same primary key in that table is written in another table also, it becomes a foreign key in the other table. So in customer table, you can say foreign key is customer zip code. So this is your basic idea of third normal form. So I hope this sounds simple, and this has helped you guys understand this. So this can be asked in different ways when it comes down to interviews. I'll repeat, it can be asked in multiple ways. One, you can expect the same question like explain, so you know database, you know DBMS. So what kind of dependencies are there, or what is transitive dependency, or what is fully functional dependency? Instead of directly stating everything in detail, that can also be asked. So I have one more question, which is candidate key in it. There are no candidate keys here. There are no other candidate keys. If you want, you can take phone number as candidate key if it is unique for every customer name. Customer name can repeat, but each customer will only have a unique phone number. So customer phone number can be candidate key, and nothing else is a candidate key here, because everything else can be repeated, can be redundant, cannot be unique. So that's the basic idea. So with this clear, let me give you guys one hint about 3.5 normal form, after which I will directly go on for fourth normal form, because again I'll repeat, I will not be going through 3.5 normal form in detail, because it's very similar to third normal form. So the basic idea of 3.5 normal form is also called Boyce Codd's normal form. So the idea here is that boys got normal form or 3.5 normal form. For anything to follow this first rule must follow third normal form. And second rule is that, think about this guys, for any functional dependency, see, here's the thing. Basically what it's saying is everything must be functionally dependent on the super key. Super key as in other words, your primary key. That's basically the idea. So you guys can take up an example to understand how exactly 3.5 normal form is slightly stricter. It's slightly different than third normal form. There's not much of a difference at all. It's basically third normal form with slight changes. That's it. So I will not be focusing much on this. I'll repeat this, guys, because we have the major parts, that is joins, fourth normal form, fifth normal form, and questions on SQL hacking, which we will try to go through. So for now, just remember this. In here, the idea is that whenever something is dependent, it must be dependent on only directly the primary key. It is somewhat very similar to this. There's just slight changes to it. So if you guys are interested to through learning more about this, you guys can do the same. But let us move on to the next part, which is again our more and more important, slightly complicated questions, which we will expect more and more. Let's look at them. So the important part that comes up is fourth normal form. Here's the basic idea, guys. Here's basically how it works. So for anything to be in fourth normal form, first thing, it must follow not third normal form, it must follow 3.5 normal form. So when it follows 3.5 normal form, you have to make sure that there is no multi-valued dependency. Now comes one more concept, like we have learned things like, let's say, partial dependency, that is transitive partial dependency, fully functional dependency. Here there's something called functional dependency. Now what is this multi-valued dependency? What exactly does that mean? To understand this, let me give you guys an example. Think about this. Again, this is to mainly reduce redundancy as well. This is mainly to reduce redundancy. So the idea here is that, let's take one example. Let's call it as customer, and each customer, let's say, has a customer ID. Along with the customer ID, let's say they have some unique orders or something like that. Better than customer ID, let me take student. It is much better. It's easier for us to understand. Let's take this student table. Each student will have an ID. Along with the ID, let's say the student goes through a course, and apart from the course, the student has a particular hobby. So the basic idea is, let's say the student ID is 1, 2, and 3, and the idea here is student ID 1 goes through, let's say, two courses. For instance, one is C and the other is Java, and the hobby of student 1 is, let's call, sleeping. Let's say student 2 on the other hand is only going through Java, and let's say JavaScript. Let it be. Let's say their hobby is gaming, and let's say student 3, again, let's assume that the course that they are going through is, let's take up anything, for instance here, DBMS, and the hobby is also, let's take it up as gaming. So when you guys observe this, I have multiple values here. This can't happen. It's not in first normal form at all. So I need one more row stating student ID 1 is going through Java also, and his hobby is sleeping. So I can remove this here. So now there is no multiple values. So you can state that in this case, your entire unique key should be combination of student ID and course. It can't just be student ID because it repeats. It can't just be course because multiple people can take same course. It can't just be hobby because multiple people can have same hobby. It should be combination of student ID and course here. But now if you guys observe, what if one student is going through 5 courses? If one student is going through 5 courses, this hobby is also written 5 times here. Like student 1 is going through something else called machine learning, for example, and his hobby is again sleeping. So for student 1, I'll be having many rows depending on how many hobbies and how many courses he has. So to make sure that such multi-valued dependency is reduced, think about this, guys. This one hobby, same thing, is dependent on multiple values of this. So to reduce this, what we are going to do here is divide it again into 2 tables. First table will be student and the course, and the second table will be student and the hobby. So when you take first table, student and course, 1, 1, 2, 3, I need the same thing because student 1 is taking up 2 courses, C and Java. Student 2 is taking up JavaScript, and student 3 is taking up DBMS, let's say, for instance. Here I can't have any one as primary key, so primary key should be student ID and course as well. So I'll just write here student ID and course. So I'll just make sure that this is visible for you guys over here. Perfect. So similarly, you need one more table called student and hobby. Here just give the same thing, student ID and hobby here. Now let's take 1, 2 and 3. Here when you talk about hobby, student 1 has hobby as sleeping, student 2 has hobby as gaming, and student 3 has hobby of gaming as well. Now if you guys observe, if student 1 opted for 10 courses, we are not writing the hobby 10 times next to it. Instead, we are writing the hobby in a separate place only once. That's the basic idea. So here you can say primary key is just student ID. So this is basically the whole concept of fourth normal form. So I have one more question by someone asking about triggers and views. All right, I'll make sure to go through triggers and views by end of this session. We have a lot to go through. I'll make sure to go through those as well. So followed by this, the final thing that you guys need to know is called fifth normal form when it comes down to DBMS. So let me just explain in short what exactly is this fifth normal form. So the basic idea, guys, just observe and remember this. For any table to follow fifth normal form, first it should follow, as we know, fourth normal form. And the next thing is, it should not have any join dependency. Now, what is this new dependency again that we are getting one more join dependency? So basically, join dependency is, again, before going for join dependency, you also should know this is also called project join normal form. It's also called the same. So basically, this is what join dependency means. Think of this, guys. Let's take something like we have a course and we have a trainer taking up a course, and let's say each student belongs to let's say a college or a semester or whatever it could be. So here the course we take is, let's say, Java and DBMS and JavaScript and so on. So let's say a trainer for Java is, let's say, trainer John takes Java, then trainer, let's say, Jane takes DBMS, and let's say trainer John also takes JavaScript, and let's assume trainer Jane also takes JavaScript, and let's say they handle it for semester, different semesters. John handles it for, let's say, 7th semester, for instance. Jane handles it for, let's say, 5th semester, for instance. So let's say this is 4, this is 5, whatever the number, let's just take it up. So if you guys observe this, the basic idea is here John and Jane both take classes, both take JavaScript over here. So if you want to add some other data, like for example, if you want to add more data here to understand clearly, like with who takes JavaScript particularly. So it's, you need to do extra work to identify for which semester and who takes it. So the basic idea here is, in order to make queries easier, in order to make sure that we can perform this joining easier as well, we will be dividing this into 3 separate tables. That is, first, which course is taken by which trainer, one table. Then which course is for which semester, another table. Then which trainer takes for which semester, because there should not be confusions here. Because if you say John takes JavaScript but for which semester, or John takes for one semester but which subject, so all of these, when you look at multiple data, it may be slightly confusing. So we will divide it into multiple tables here. The basic idea here that you guys just need to know here is, when all tables have something called all tables are supposed to have something called join dependency. I'll explain in short what join dependency is, because I'm not going to go in much detail with this. Please note, students, will not go in much detail with this because this is not normally asked, but if it is asked, you should at least know this. So the idea here is, there should not be any decomposition of the table by which you will be able to lose data. So here there could be, in short, in this case it violates fifth normal form because it has a join dependency. There's a dependency that course semester based on the trainer John and Jane taking same course but for different semesters. It's slightly confusing, so we can divide that to make it easier. So again, let's not focus on this much, and let's focus on our major concepts, major interview questions ahead that comes up. So this is just one simple example that you can take, but out of this, the common questions that you guys need to know is first, second and third normal form, which is often asked, 3.5 and fourth also, but fifth not much. But if you guys want to know fifth a lot in detail, go through joins. If you don't know joins, this may be slightly difficult to begin with, but once you get to know joins, it becomes a little easy. So going ahead from this, let us just look at SQL. So one of the common questions that you guys can expect is data types in SQL. What are the data types that you have in SQL? You have int, you have varchar. There's nothing called string. String is basically replaced as varchar. There's something called varchar. There's something called varchar2, and so on. There's a lot of different things that you guys can have. So if you are interested in this, what I would suggest is, go through certain data types, like there is date time, there is timestamp. These are certain things that are hugely important, which are often used in real life as well. So these are some things that you guys need to know. So they may ask you questions like, you have two things like varchar and varchar2. What is the difference between them? Or you have date time and timestamp. What is the difference between them? Here's the thing. Date time is constant. It won't change. Whereas timestamp keeps changing based on your computer's time zone. If your computer time zone is changed, the timestamp changes automatically. But date time, it doesn't depend on time zone. It doesn't depend on your universal time zones. That is, UTC, you have plus 5:30 and so on for India and so on. So for each one of these, if you keep changing the time zone, your timestamp value changes accordingly. If you don't change time zones, timestamps do not basically change. So I have one question I have received here. What is the difference between truncate and delete. See, truncate is used to remove all the records from the table. I'll repeat, truncate is used to remove all rows from table, whereas delete, you can of course delete all rows or anything like that, but delete is used to delete, in other words, particular rows as well. So generally what happens is truncate is specified as a DDL command, delete is specified as a DML command. So there's a reason for that. The major reason is truncate is used to remove all records, delete, again, you can conditionally do whatever you would like within this. So followed by this, let's go ahead through our um, data types that we just need to know. I'm just going to give you guys one simple example to understand how tables can be created. Again, for most of you guys, when it comes down to this interview, I will repeat, you will not expect questions like create a database or something like that. That is highly difficult to expect something like that. But here, the questions that you can possibly expect are, one of the uh, command will be given and you will be asked explain what happens with this command, or try to work through this command, or try to figure out whether this command works or not, or which which clause of this command has higher preference, or things like explain this clause of a command. So certain things like that can be expected. So here's the basic thing, guys. Let's start with something like this. I'll just give you guys one very simple example. See, when we talk about select star from customers, for instance, if I run this command, what will execute first? Will it execute select star, or will it execute from customers? See, in this case, you guys need to know one basic thing, that is which which clause evaluates first. Always from evaluates first and then select. Unless you know which table, you can't select the data from that table. So always in this case, from executes first. From executes first. I'll tell you guys why this is hugely important in a minute. From executes first and then select executes. So when you say select star from customers, star means everything. There's no condition, you have to select everything. So when you say select star from customers, you go to customers table first, and then from customers table you are selecting everything. It's not select everything and then go to customers table. That can't happen. So the evaluation is important when it comes down to this. Remember guys, one of the important part is evaluation, that is from first and select next. Even though you write it as select star from customers, and it's case insensitive, you can write it as uppercase, lowercase, or anything that you guys want to do. So going ahead from this, here's the basic questions that you can expect when it comes down to these things. You guys are going to be given certain clauses to explain. This is a very common question. I'll repeat, you will be given certain clauses to explain, and here's the common clause that comes up. But before going to that clause, let me give you guys one simple thing. Guys, please observe and understand this very, very clearly. I'm just going to start with one simple thing over here. See, guys, and this is what you guys need to understand very, very clearly, because this is a kind of an important question which most of us go wrong in. So please observe this very clearly, guys. Think about this. Select, I don't want to select all of them. I only want to select last name and first name. So the last name is specified as contact last name. I'll select that, and contact first name, I'll select this. So once I run this, think about this guys. First thing that it shows is an error. Let me see if I have made sure to use this data correctly. So let's just check once. So once I've run this, yeah, the table name was in uppercase, unfortunately. So I'll just select contact last name and contact first name from customers. So when you run this, you're only going to get contact last name and first name. Now let's say I don't want it to look like contact last name and first name. I have received one question for notes link. I will be sharing that by end of this session soon, not to worry. So let's observe this, guys. Please note, let's say we have contact last name and contact first name, which I don't want to display as contact last name and first name. So we have something called alias, where I will display it as last name or just last, and first name I'll just display as first. That's it. So if I run this, instead of contact last name, contact first name, it will display here as first and last. So that's the basic idea. With this clear, now I'll go for the interview question that can come up within this, because we need to know this in order to find out. So all that I'm gonna do here is, guys, observe, I'm selecting contact last name and I'm naming it as last. I'm selecting contact first name and naming it as first. If I don't do this, again, I'll just show this for your reference. I'll get it as contact last name and first name as the column names. So here I'm going to give a condition. We know conditions are given by where. So where I will say, you can give any particular condition like contact last name should be exactly king, for example. Let's say contact last name let's say, for example, sorry guys, let's say contact last name should be, for example, king in double quotes. Let's see if it works first. Now when you run it, only the ones with whose contact last name or king will be written here. Now I'm just going to make one small change. As last, here contact first name as first. Since I'm naming it as last and as first, I want last name to be king. So I'm going to copy this last and replace contact last name as last. If you guys observe this, what we are doing is contact last name will be replaced as last, contact first name will be replaced as first. I'm selecting in customers where this last whatever we have should be king. If you run this, it won't work. If you take it as contact last name and run this, it works. But when you try it with only last, it won't work. So the reason here, guys, is where you need to know evaluation. This is a common thing that you guys need to know, because you may have a question where you're expected with a query asked like, why does this not work? So the idea here is the order of evaluation is always like this: from, and then, where, and then select. This is the order of evaluation. Always remember this, guys: from, and then where, and then select. And you have order by, if you have, it will be done at last. So observe this: from executes first. Let's take this command and write it down here to understand, because this is where you guys will understand this perfectly. So from should execute first. So let me take from and put it first. After from, I'm supposed to have where I'll put it here. After where, I'm supposed to have select. So select, I'll put it here. So in order, I've written it as from, where, and select in the order of evaluation. Now from customers, I'm selecting where last equals king, but last I'm defining it in the next line. Observe, guys, last we are defining it in the next line, but we are using it in the previous line. So when you talk about order of evaluation, even though here you're saying contact last name as last in the beginning, here you're saying last at first and then defining last later on. So that can't happen, that can't work. That's why you get error. So evaluation, order of evaluation is something hugely important. So in SQL, they may ask, okay, you guys know the basic commands of SQL. What commands do you know? How does it work? So what is the order of evaluation or something like that? If it is asked, you guys need to know this basically. So if you are willing to learn a lot more in this, there's order of evaluation for basically every single query. So you guys can go through that and learn it as well. So you have something called where clause where you give conditions. You have something called order by clause where you give particular things like uh, whether you want to order it in ascending or descending order and so on. So again, there may be many of you guys who are from different branches. I want to make sure that this point reaches out to all of you guys. There may be some of you from different branches like EC, Triple E, Mechanical, and so on, and you guys may feel like, hey, we don't know order by, we don't know where, we don't know from, we don't know select, we don't know all of these together. So right now, within a short time, it's highly difficult for us to learn entire SQL. But what I will be focusing on, or what I am focusing on here in the time right now, is to show you what sort of important questions you can expect, so that you guys can understand from this what you should focus on in basics in order to learn later on. That's the basic idea I'm giving to you guys. So observe this, guys. Followed by this, the other very common questions that you can expect, and this is something that is most often expected. One of the most often expected is something called joins. They will ask you what are the different kinds of joins you have. You have something called left join, you have something called left outer join, you have something called right join, you have something called right outer join, you have something called equi join, you have something called natural join. So there, and you have again something called Cartesian join, or which is also called cross join. There are so many different kinds of joins. So there are going to be questions like, okay, you know SQL, then you must know joins. What are the different kinds of joins that are there? Can you explain them? So when this question comes up, here's the basic idea, guys. See, you have a lot of different joins. I'm going to just try to explain this in short, in simple, so that you guys can be able, can answer this as easily as possible when it comes down to interviews. So think of this, guys. Let's say there are two tables. Let's say there are two tables called customers. I'll make it white. Let's say customers and orders. Now you may want on all the customer data, whether they have ordered something or not ordered something. This is your left table, this is your right table. If you want everything, whether they have ordered something or not, you say this is left join. If you want all the customers, if they ask you a question, I have two tables. This is the question you may expect. I have two tables. One is a customer and another is orders. So I want to get information of all customers who have not ordered. They are joined. I want information of all customers who have not ordered anything. How do I get that? That means you need to get the data of customers which have no intersection. That means they have not ordered. So all customers who have not ordered come here. All orders by non-customers come here. All customers who have ordered comes up here. So when you say I want all customers who have not ordered, you basically get this part of the entire table. So this is called left outer join. If you want to get all data of orders which are by non-customers, you get right outer join. If you want to get all information like customers who have ordered, that is your intersection. So all of these are different kinds of joins that you guys just basically need to know. So for now, the first couple of simple things you guys just need to know is something called left outer join, which is from left table, which is not there anywhere else. Right outer join, which is in right table but not anywhere else. Left join, which is in left table as well as intersection. Right join, which is in the right table as well as intersection. To get that, we call it as these different joins. So followed by this, one of the common questions that you guys can expect. Okay, I have one more question. Is this much knowledge enough for non CS or IT? What I would suggest is, see, as much knowledge as you can gain, do that. Don't ever think that learning this much is enough. What we are going through is the most common questions you can expect, but apart from this, you may just expect some other questions as well, but we are going through most common questions that you can expect in this. So hopefully, we do hope that you get questions from these itself and you get to clear it. But in case you don't get it from just this much questions, you would need to know a little more as well. So that's the basic idea. So following by this, equi-join is where, think about this guys, I need to know where customers have ordered a product which is named something like, let's say, sanitizer. I just want to know who are the customers who have ordered a product which is named sanitizer. So I am joining with equal sign here. I'm joining by comparison with some equals. This is basically called equi-join. That's it. There's nothing special about it. Equi-join is just where you're comparing between two tables and you're saying, I need to make sure that there should be something equal in both. That is basically the case. So I should find all the orders by customers which have something exactly $50,000. So that is where you are comparing equally. That is basically your equi-join. There's not much complicated about this. It's something this simple that we just need to know. So followed by this, once joins are completed guys, we'll just look at a few advanced topics that we need to know when it comes down to this. So let's go ahead to one more thing that is called, now that we basically know what is equi-join, let us look at natural join. Remember, natural join is a type of equi-join. Now, what exactly is this natural join? Here's the thing, guys. The idea for natural join is, see, first, you know, equi-join is where when they are equal in left table and right table, only that data are obtained. Other data are not obtained at all. When you talk about natural join within equi-join, only unique data are obtained. This is the basic idea. Just remember this, guys. Natural join means, to understand this better, to understand this really better, in join, you need to identify which column is joined by which column. Like for example, observe this very clearly, guys, because if you are asked what is natural join and cross join, which are two hugely important questions, you need to know how to answer this. So let's say you have a table customer. I'm going to remove this. Let's say you have a table called customer, and let's say you have a table called orders. In customers, you have a column called customer underscore number, cu underscore number. In orders, you have it as cust underscore number. So if this is the case, you cannot make natural join. Natural join can only be made when column names which are to be connected between the two tables, the column names which are to be connected must have same attribute name. In other words, column names which are to be connected between the two tables should be of same name. If they are same name, then you can perform natural join. It will naturally figure out which column names are equal, which column names are same, what should be selected accordingly, and it will automatically join the two tables and get you the results. If such column names are not same, then you cannot do natural join. You will get random outputs, random answers. You should do some just equi-join. You should say that where customer number here is equal to customer number here. You should particularly specify they are equal. In natural join, you don't have to specify any equality. You don't have to specify anything. You just say you're joining these two tables because it will automatically identify which column names are same and how they should join. that is natural join. It will naturally identify column names within two tables must be same of same data type. Only then they will combine. This is the basic idea, guys. Finally comes up something called cross join, where a lot of us find out difficulty to understand what is cross join. Guys, think of this. Let's say I have one table which has three rows of data, let's say 1, 2 and 3. I have another table which also has three rows of data, 1, 2 and 3. In a cross join, first row is connected to first row and it is displayed. First row is connected to second row, it is displayed. First row to third row is also displayed. Then second row to first row, second row to second row, second row to third row is connected. Then third row to first row, third row to second row, third row to third row is also connected. So total 9 rows are displayed. Now, why do we need to do this? What sense does it make? Think of customer and order data. Let's take, for instance, you have customer data and order data. There's customer 1, 2, 3, their order 1, 2, 3. Customer 1 has ordered 1, customer 2 has ordered 2, customer 3 has ordered 3. If you do cross join, customer 1 data is printed along with order 1 data in one row. Customer 1 data is printed along with order 2 data in second row. And customer 1 data is printed with order 3 data in third row. There's no point in this. There's literally no reason to do this. But when you look at some use cases, think about this. In table 1, there is locations. That is departure locations for an airplane. In table 2, there are destination locations for an airplane. So you want to find out what is the distance between each departure location and each arrival location. You want to find out distance between first, let's say there are 3 departure locations and 3 arrival locations. You want to find out distance between first departure to first arrival, first departure to second arrival, first departure to third arrival. Also, second departure to first arrival, second departure to second arrival, second departure to third arrival. So to get to know all these as 9 rows, if you want to calculate the distance and print, then we use cross join. In cross join, each row of first table is connected to every row of second table. That is how you get to know these kinds of data. So it is used in such case scenarios. So remember this. So for example, let's take it as location distances between locations of first table and second table. This is one real case example. So in interviews, if you're asked, so you know about these joins, where do you use these joins, or what do these joins do? So you can explain at least with such cases of how these basically work. So followed by this, there are a few other questions as well, guys. So you may get questions like, why do you need normalization? We know that it is used to remove redundancy. It is used to make sure that the table is as efficiently stored as possible and so on. And there are some other things that are called triggers, views, and particularly a few other things which I'll focus on further on. But for now, let's focus on the first thing. What is a view? See, guys, let's say you want to take some part of a database and show it separately, and that should not affect the database. In other words, let's say you have a part of the database, sorry guys, you have, let's say, a table, and you want to show some part of the table separately, and you take that some part of the table separately, show it in a separate memory location or something like that. So once you show it in a separate memory location, whatever you do in this, it should not affect the original table. So this is just called a view of a table. In other words, a view is a virtual table. It's not the real table, it's a virtual copy of the table where you literally do not have it stored in the database. It is just temporarily stored just to show you some things, to search something, to modify something. That is the basic idea. And other thing that you guys need to know, a couple of other things that I'll focus on here is, since we got to know basically what is all the joins, I also forgot to point out one more join, guys. Please note, that is called inner join. Inner join is where you basically get intersection of the two tables. Only intersection of the two tables is obtained by inner join. If you go for full join, it is union. There is one more thing called full outer join. Full outer join is union minus intersection. Whatever is within the intersection of both tables, except for that, think about this, you have two tables, except for this intersection, everything else you want to print, that is full outer join. Full join means everything. Inner join means only the intersection. That's the basic idea. So you guys can just know this in short when it comes down to this. So followed by this, if you guys would want to know more, I would suggest you guys to go through as much as possible. I'll just take a few questions before ending the sessions, because and I'll share the whole content here so that you guys can go through the same. Now, one of the point that I've been asked is, explain what exactly is a trigger within SQL. See guys, a trigger is often called a stored procedure. It's called a stored procedure as well. So here's basically what it does. It waits for an event to occur. Like for example, in a database, there is birth date stored. So the moment someone's birth date matches the current date, you need to send a mail stating that there's a discount for you. So that trigger, until that trigger occurs, until that special condition or special event occurs, it waits. The moment that event occurs, a function or a stored procedure is executed. This is the basic idea. So a stored procedure is triggered at a particular event. Like for example, on a particular day, people whose names start with V are given a discount, or the moment a person's sales, or the moment a customer's purchase goes over 1 lakh, we should give them a special coupon. So this trigger keeps on checking if the purchase of a customer goes over 1 lakh. The moment it goes over 1 lakh, the automated stored procedure to send a mail will execute. That's the basic idea of a trigger. I hope that sounds simple and easy to understand. So I'm giving a real case example. You can also take an example where the moment a trigger is encountered, the moment a person purchases for at least 1 lakh, the person's or the customer's status should be taken as VIP customer. So there can be something like normal customer and VIP customer in another column that will be updated the moment this happens. So such a trigger can also be put up. So these are basically triggers that you can take up. Views are basically, as we noted, virtual tables which are stored temporarily and will not affect the real data of table. Temporarily. Perfect. So these are the basic things that you guys need to know at least. Apart from this, I would suggest you guys to learn as much as possible, to learn so that you guys can work through these. So this is what I would suggest. So learning as much as possible is always a good thing. And in triggers, if you guys want to know, there is something before trigger, after trigger. That is something like before an event happens, trigger, or after an event happens, trigger. So these are some things that you guys need to know. So I have one question. What or where exactly does trigger come up? Do triggers come up in DML? Do triggers come up in DDL? Where exactly triggers come up? Here's the thing. triggers are not a part of DML or DDL or anything like that. See, if you create a trigger to delete a table, that's a DML trigger. If you create a trigger only to do something like update a column data, that is DML trigger. That's the basic idea. So I have a question: what is the need of view? Views are used to, like, see, you may want to take certain data, snapshot of a data, or use it for some purpose, while real data keeps on updating later on. We generally take it in view. So I have one more thing, that is order by and group by. See, when you talk about order by will only put it in ascending or descending order. I'll point it out. Order by puts it in either ascending or descending order, whereas group by will make it distinct. So if there are 10 rows with a single customer's data, instead of 10 rows, group by will make a single row available, not 10 rows. Whereas order by will only make it ascending or descending. That's the basic idea. So this is the whole concept. So these are the basic things that you guys need to know. I'll be sharing this content over a file online, and I'll share the same to you guys. So one of the first things that I want to ask you guys today is, just let me know, guys, what do you think of this session so far? In 2 hours, it's very difficult to learn everything in DBMS, but we have tried to learn as much as possible within this. It's very difficult to learn everything in a short time. So we are trying to go through as much as possible. So you guys can please provide your feedback of however you felt, whatever you guys thought. And we will be having our sessions tomorrow also on what is particularly data structures, algorithms, as well as further things like recent trends. So make sure you do subscribe, check out our channel, and keep following all the videos, which will keep on updating over here. And I'm just going to share the link for today's sessions for your reference. Anything more on this, you guys can feel free to go through as much as possible as well, because this itself is not enough to go through everything when it comes down for your entire preparations. So going ahead from this, I hope you guys had a good time. I hope you guys found this 2 hours of sessions useful. We will make sure to conduct more sessions, particularly on data structures, algorithms, and recent trends like machine learning, deep learning, artificial intelligence, as well as things like blockchain, IoT, and everything. So we have sessions planned out even on those. So make sure you guys do go through our sessions in the coming days as well. And we hope all of this are really useful for you guys. Do check out more of our content as well. Thank you guys for joining in for this session today. I have a question on please share yesterday's material also. It's in the link in the chat of yesterday's video. You can access from there. No issues with it. So we'll end our session here, guys. Thank you guys for being a patient group of students to go through the whole thing. We'll catch up in the next session soon. Have a good day, guys, and happy Diwali.